So today we will be talking about nitrogen. A lot of nitrogen is in the air. About 78% of the air is nitrogen. In this video, we will be discussing the nitrogen cycle, the Haber process, displacement of ammonia from its salts, and nitrogen fertilizers. So now we're going to be talking about nitrogen and how it can be a pollutant. So oxides of nitrogens are actually pollutants. These oxides form due to nitrogen and oxygen reacting together inside hot car engines. Their harmful effects are that they can cause lung damage and breathing problems, and they can also form acid rain. So nitrogen and oxides form in car exhaust because the air gets so hot that nitrogen and oxygen react. You can remove the nitrogen oxide by using a catalytic converter, which is present in many modern cars. These contain a catalyst that catalyzes the conversion of the oxide back to nitrogen and oxygen. So how this works is, in the A section, the nitrogen dioxide is reduced. So it goes into the catalytic converter. It is reduced and the products flow to the B section. In B, the oxygen from A then oxidizes other harmful gases. For example, carbon monoxide and carbon dioxide is formed. So you can see these two equations here.
These are the raw materials needed for the process of making ammonia and how to obtain them. So firstly, is hydrogen gas. You can obtain it by reacting natural gas, which is mostly methane, with steam, or cracking oil fractions, which is involved in organic chemistry. The second raw material is nitrogen gas, which is obtained from the air. When hydrogen is burned in the air, the oxygen combines with the hydrogen and leaves nitrogen behind. This is a summary of the raw materials needed for the Haber process, as well as the reactions needed. So this is for nitrogen and this is for hydrogen. Both hydrogen reactions require catalysts. So please pause the video if you want to read more on the information. This is the nitrogen cycle, which describes the movement of nitrogen through the environment. However, this is not included in our syllabus and it's just for your knowledge. Go. The conditions required to make ammonia is that the pressure needs to be high, which is 200 atmospheric pressure, and the temperature should be moderate and it should be 450 degrees Celsius, and iron is the catalyst which is used in Haber process. Because for the high pressure favors the side of the equation with the fewer molecules, which is the ammonia. The forward reaction is exothermic, so a low temperature favors it. But then, at a low temperature, the reaction is too slow. That's why a moderate temperature is required. For iron as the catalyst, speeding up the forward and backward reactions equally, so the equilibrium is reached faster. And we have to note that a catalyst does not shift equilibrium. And to remove the product, the reaction mixture is cooled to remove ammonia as a liquid. This prevents it from breaking down to nitrogen and hydrogen again.